5,
4,
3,
2,
1,
go.
Hello and welcome to Space Now, the space news podcast from the National Space Centre that goes beyond the headlines. I'm Ed Kellon-Turner.
And I'm Dhara Patel.
And today we're focusing on Venus. A Japanese mission has recently ended operations. So what did it find out? What else is there to find out? And what did we already know before this mission? But first, it's time for our Space Wows, what we've been seeing in the headlines. Dara, I hear you've got a good one this week.
Well, it's one
5,
that definitely
3,
piqued my interest.
1,
So it's an image that was revealed on bonfire night. So while we were gazing up at the night sky and looking at fireworks, there was an image released by a mission called Euclid looking at the dazzling lights of stars in a nebula.
So what is a nebula, first of all? I suppose that's something we should explain.
So you're right. So a nebula is a huge cloud of gas and dust in space. And this particular one that Euclid imaged is a part of the Orion complex. So anyone that's familiar with the constellation of Orion, a lovely constellation to look for in the winter, you may notice there's a lot of fuzzy patch in the sword of Orion. That's Orion Nebula. And that is one part of the Orion complex. And so this nebula is a different part. And what's different is it's actually a dark cloud. So if we looked at it in visible light, we wouldn't really see anything. But Euclid has managed to basically open our eyes to what is actually hidden there. So I want to take ourselves back to what Euclid is. So anyone that's not heard of the Euclid mission, it launched a couple of years ago, and it is an infrared mission. So using infrared light to basically survey a third of the entire night sky. And you might think, well, we've got telescopes like Hubble and JWST. What's Euclid got to offer? Euclid has unprecedented detail and also a wide field of view. So what I mean by that is, in terms of how much it can image, there was a stat that I read, or a comparison. Every day, Euclid is able to observe as much of the sky as Hubble has in the past 20 years.
Wow, in a single day.
In a single day. Because its field of view is about 3 times the size of the full moon. So that means that every time it's opening its eyes or looking up, it can see a part of the sky that's 3 times as large as the full moon, much smaller than Hubble can. And also it's got such a wide field of view that it can actually see a vast expanse of the sky. So like I said, it's looking at a third of the entire night sky. And so it's just doing some really incredible things. So what I wanted to share was the image that was actually released. So this is like I said, a dark cloud, but it's actually where stars are forming. So you wouldn't see it with our eyes, but using its infrared instruments, it's been able to pick out thousands of stars that have been hiding in this nebula. And anyone that wants to see the image, you can go online, and on the ESA page, it is an ESA, European Space Agency mission, you can click into some of the parts of the image and it magnifies it. And you think that with an image like that, if you magnify it, you're going to lose some of the detail. You can see individual stars, Ed. You can see stars that are blowing off the gas from around them. You can see stars with jets emanating from them as they actually develop into their own star systems. So this is what piqued my interest. Anyone that's not heard of Euclid, it's a relatively new mission, but it is doing some amazing things and an incredibly crisp, detailed image. If you haven't seen it, honestly, please go and have a look at it.
That's definitely a bit of homework then for everyone listening at home.
I definitely feel like we should.
Absolutely.
And what have you got for this week's Space Wow?
Slightly different. I've been looking at a little bit of human spaceflight, and something that piqued my interest because I was kind of thought for the split second, well, why does that even matter? And we're actually looking at the Tiangong space station. So probably have heard of the International Space Station, which is a group of international partners all coming together to form this one space station. China is not actually allowed to collaborate and have any part of the International Space Station due to a variety of different politics that I'm sure we'll leave David to because he loves talking about the politics behind space. So China basically just made their own space station, the Tiangong space station. And aboard this, Chinese astronauts, we sometimes call them taikonauts, they actually cooked chicken wings and steaks. They had a barbecue up in space.
An actual barbecue?
Sort of.
Okay,
It wasn't
I knew
a
that was
barbecue, sort of like we have here, for one very specific reason. And the same kind of problems that we would have with a barbecue here on Earth, there is up in space. You see, in space, you don't really cook food. You reheat food, or maybe you rehydrate it if it has been dehydrated for going up into space.
So like making mash, you add water, you hydrate it, and you kind of make it edible.
Yeah, exactly. Okay. Whereas this was one of the first times we've actually properly cooked food and protein. There was sort of a test of this on the International Space Station as well. They had to go at baking cookies. So I was like, yeah, it's already been done before. But a fun fact you probably didn't know is those cookies took about 2 hours to cook, and they weren't even properly cooked by the end of that. They made loads and loads of batches, and they had to keep increasing the time. Because in space, it doesn't cook properly. Ovens don't work the same way that they do here on Earth. For one simple reason, there's no gravity. So here on Earth, hot air will rise and cold air will kind of fall to the ground because of density. So higher density means it will fall down to the ground. That doesn't happen up in space.
So our ovens basically work through convection, right?
Exactly,
the currents that you get with hot air rising, okay? And we don't get that in space because of the lack of gravity.
Exactly. So they have to, on the Tiangong space station, they have to have a very special oven that's got basically a fan in it, which, you know, lots of ovens do now, but it had to be really specialized to make sure it circulates that air all the way through because it can't also focus on convection. But also, going back to the kind of barbecuing analogy, you can't use a barbecue here on Earth inside.
Yes,
because
that's a big problem.
Big problem. There's lots of harmful particles that will come from that, causing respiratory issues. This is a thing on the space stations, and they have zero ventilation, pretty much. So any dangerous particles are really going to hang around and cause problems for a long time. Yes, they might be pulled into the ventilation systems on there, but they're not going to be gone.
They're not going anywhere.
They're not going anywhere. They're not escaping into the atmosphere. So this oven had to be specially made. It's got this really good extractor hood to make sure there is absolutely no particles around left over. So they had to go. They kind of fried off these chicken wings and these steaks. And I said earlier it took them 2 hours to make some cookies.
Oh, how long did it take?
28 minutes.
Not bad.
So kind of about the same as you might expect here on Earth. And I was reading into this about how important they're saying it is for this. And it's all about mental health. Because if you're going to be going somewhere really far away, a mission to Mars is going to take about 2.5 years to go there, hang out there, and then come back, basically. So about 2.5 years. That's 2.5 years without proper food is sort of what you're looking at. So being able to cook real food, chicken wings, or a variety of different things inside what is essentially an oven would massively improve the mental health of astronauts as they're going to these faraway places.
What's next? We've had chicken wings. What's next on the menu?
Who knows? I'm not sure what I would like if I would go up into space.
Don't get us started.
I think I'd like just astronaut food, just for the experience of having that astronaut food.
Yeah, I think I'm with the Chinese astronauts here. I think after a while I'd be missing like home cooked food. I'd want to be able to cook.
I think I'd get tired very, very quickly, but you at least want the experience to start off with. But now we are focusing, instead of I said maybe going to Mars, we're going to another planet. For our main part of our content now, we are heading to Venus. And we're also talking about another Asian country heading to Venus, which is Japan. The Akatsuki mission, a Japanese mission, so from JAXA, recently ceased operations around the planet. Should we do a quick little fact file about Akatsuki? Kind of talk about the mission, if you want.
Yeah. So you mentioned this Japanese mission. It's called Akatsuki, but it's also known as the Venus Climate Orbiter. And the reason is that this was a mission that was designed to learn about the Venusian climate. So it basically launched back in 2010. And unfortunately, it was supposed to get there by the end of 2010, but it didn't arrive for a further 5 years. And that's because of an engine failure. So you may have heard as well, the idea is that once we're on our way to a planet, whether that's going in or out, we usually use something called engine burn. So we fire a thruster to sort of point you in the right direction, get you to where you need to be. And unfortunately, at the exact moment that they wanted to burn the engines to get it to go to Venus, the engine had failed and they actually ended up going around in the sun, or orbiting the sun. But miraculously, and this is something that I love about space, is that there's always creative and inventive ways that engineers come up with to resolve situations like this. That could have ended in, we spent years coming up with this probe and now we're done. We just managed to miss the burn. But they actually used thrusters that are used or designed for less powerful maneuvers. So things like adjusting your attitude, which is like your direction in space, or fine adjustments. They used those thrusters to eventually get it back into orbit around Venus. So arrived there December 2015 and actually operated for 3 times longer than it was proposed to.
Excellent. And I mean, it's incredibly lucky, I suppose, that they even got to have another chance at getting into orbit, because I mean, most missions, say if you were going further out into the solar system where you've got much longer years planetary orbit periods, if you miss it, that's it, you're done.
You could be thrown off by years, couldn't you?
Yeah, and I mean, this happened also with the, another JAXA mission along with the European Space Agency, which was Bepi Colombo. Also had thruster problems getting to Mercury, but some very, very smart people ended up getting
putting it back on trajectory.
Not in orbit yet. Hopefully, fingers crossed.
It's almost there.
We'll be talking about Bepi Colombo literally this time next year. But what did Akatsuki kind of find out about Venus when it was there?
So it's basically looking at a cloud layer about 50 to 70 kilometers above the surface of Venus. And what we find in this region is there are lots of strong winds. So Venus already has a very thick atmosphere. But one of the things that it has helped spot is this idea of winds that are 60 times faster than the planet actually rotates.
Because Venus rotates very slowly, doesn't it?
Yes. So Venus takes about 243 days to spin once on its axis. So compare that to the 24 hours of the Earth.
Yeah.
Incredibly slow. And this is analogous to the idea of, imagine I had like a cup of tea or a cup of coffee and I was like slushing it around. This is like me seeing the liquid in my cup going around 60 times faster than the cup is actually spinning it. So it's just nuts. And one of the things that Akatsuki has helped kind of determine, or at least provided a theory for, is why this might be happening. So although Venus spins very slowly compared to its year, like how long it takes to go around, it takes about 225 days to orbit the sun. So they're not exactly the same, but roughly the same amount of time to spin on its axis as it is to orbit around. And what that eventually leads to, if those two were in a perfect match, is something called tidal locking.
Yeah, so a bit like the moon is currently with Earth.
Exactly. So it's always the same side of the planet or the moon facing towards, in this case, the sun. And we think that when we think about sort of like exoplanets, so these alien worlds that are, orbiting distant stars, many of them we found are tidally locked. So they've got the same side facing towards their star. And unfortunately, it kind of leads us to this presumption that perhaps they're not very habitable, because what you'll end up with is a super hot, scorching one side and a really cold, like far side facing away. But what Akatsuki has kind of inferred is that perhaps it's actually driven by the sun's heat. So it's the sun's heat that is actually driving what are known as these like super rotation winds. And if that's the case, perhaps that's not actually uncommon on exoplanets. And so rather than having like a really hot side to an exoplanet and a really cold side, which eventually would lead to the cold side, the gas is basically freezing and almost depositing on the surface and just losing its atmosphere, that heat from the sun is actually driving winds and keeping that heat circulating around the planet. So what we might thought previously of exoplanets being tidally locked as being uninhabitable, maybe this is a mechanism that actually makes them not so uninhabitable.
That's really, really interesting. I didn't actually
But
realise
it's not confirmed.
Yes.
So it's one of the theories as to why, but it is still a little bit of a mystery. Another thing that it's actually seen is something called gravity waves, and in fact probably the largest one in the solar system. So this gravity wave likely extends almost the entire diameter of the planet. So it's about 10,000 kilometers long. So if you were looking at a picture of Venus, what you might see is like a bow-shaped atmospheric wave cutting across almost the entire surface of the planet that you can see. And what we actually think is that this comes about due to the rising of hot air. So Venus, incredibly, incredibly hot, and we can talk about that in a short while. But when that hot air rises, it can basically form this atmospheric wave, or what we call a gravity wave. And you think, well, why would that hot air rise? It's so thick. But actually what's happening is it's the likely the mountains on Venus that are basically shifting this hot air up to form this gravity wave on the surface. And it's known as a gravity wave because it appears almost stationary. So I mentioned these super fast rotating winds. The atmosphere is moving round and round, but you see this gravity
but it
wave.
looks like it's not,
Yeah.
almost not moving at all.
Exactly. And again, this idea of why this is happening, we're not quite sure, but it is the largest one that we've ever seen.
So there is still quite a lot more to learn about Venus,
Yeah.
really.
There is so much to learn. I think we already know quite a lot about Venus because there have been lots of missions to
Yes.
Venus previously.
Going right the way back to the 60s, really.
But yeah, it started very much at the beginning of kind of the space era, and you know, perhaps we can share, I guess, some of the things that we already know about Venus, and perhaps some of the spacecraft that have been quite helpful in us finding those bits.
Yes.
So you've heard of the Venera probes. So these are the Soviet probes that were sent to Venus, both to orbit and eventually to land down on the surface. So between the 60s and the 80s, so spanning the length of over 2 decades, they managed to orbit around the planet and take some of the first pictures, even before we had pictures of Mars. Some of them managed to land down on the surface, which is a feat in itself. In fact, I read somewhere that because of how thick Venus's atmosphere is, if you were to send a spacecraft to free fall down through the atmosphere, it'd probably take an hour.
Yes, yeah, and
Like-
it would actually possibly even land relatively safely, we'll say. It would still crash land, but yeah, because it's
It'd
so
have
thick,
enough of a drag to slow it down.
it'll be a bit like dropping a coin into water. It will sort of slowly waft
Make its
way
way
down.
down.
Yeah.
And we even had, actually, from some of the later Venera probes, the first kind of sound signals recording from a
Venera
different
13,
planet.
Like, what a weird thing to kind of think of, like the wind. I mean, you're mentioning the wind from Akatsuki. That actually heard that wind from down on the surface.
It's just, it's nuts that we've been able to do this. But the Soviets are the only nation to have ever landed down on Venus. And the stark reality of it is temperatures on Venus exceed 460 degrees Celsius. That's enough to melt lead, right? Like, your spacecrafts are not going to be able to survive very long. The atmospheric pressure, so it's about 90 times what it is here on Earth. Anyone that does any deep sea diving will know, the further down you go into the oceans, the more pressure you're going to feel. This is like being 900 meters underwater. And so those probes, the Venera probes, only lasted, I think the first ones for about 20 minutes. And by the end, it was about 2 hours.
Quite a lot of them didn't even make it
Yes.
properly. They was just sort of throwing something at Venus and sort of, well, we think this might survive.
Hoping.
And then the parachute kind of gets torn through because of the acid in the atmosphere, and then it's crushed because we weren't sure of the pressure.
Yeah, the cameras don't work,
Yes.
But we have had some images back from the surface, and that is really one of the things that shows how Venus is quite different to the Earth. So very barren, very rocky. Now we know it's very volcanic, but just a very hostile world. So although it's known as the Earth's twin, it is a rather different world altogether.
Yeah, and it is a little bit of a shame, though, because obviously we're talking about Venera through to the 80s, but actually since then we have not sent anything down towards the surface, really. We've sent a few more things into orbit, so ESA have sent, obviously, Venus Express around, but to actually dive into the clouds, that doesn't really happen.
It doesn't happen as much. There have been a few what we call like atmospheric probes, so those that sort of delve into the atmosphere and kind of study that. But one of the other really, I think, key missions when it comes to Venus is the Magellan probe that was sent by NASA back in the late 1980s. And what it did for one of the first times is actually allow us to penetrate down through the thick atmosphere to see what was going on underneath. So it used something called radar, which is basically radio waves. It orbited around Venus for about 4 years. And it was really Magellan that showed how volcanic Venus is. And one of the incredible things I find about this is this mission has been, expired or defunct for, since the early 1990s. 30 years on, we're still using data from it to make new discoveries. And one of those is that Venus is volcanically active. So from the Magellan data, first and foremost, we found that about 85% of Venus's surface is covered in lava. And actually the fact that there are very few craters on Venus tell us it must be a young surface. Something must be covering up the craters or some sort of geological process. But there was no direct evidence of like volcanic activity to be present. But they basically used Magellan data from about 30 years ago and looked at particular images. And this one in particular was looking at some old kind of rings around volcanic features 8 months apart. And what they noticed is that there was like a new plane that had evolved between those two pictures, basically telling us there was an eruption that had happened and a new plane had formed.
Yeah.
And similarly next to it, there was an area that seemed to have like grown in size because the crown had basically blown a little bit. So we know that Venus isn't actually dead. It's a very alive and active world full of volcanism, and there are so many cool like volcanic features on its surface as well. I heard of one called like arachnoids that looks like spiders, like some streams or vents like coming out from the center.
Because I suppose it'd be interesting because it would act slightly differently here on Earth, because here on Earth obviously volcanoes will erupt but they'll cool relatively quickly. We do have a thinner atmosphere, but on Venus the different temperatures, the different pressures, they will act very slightly differently, and we can kind of study that and see what that would look like, and maybe like spiders or something.
That Venus doesn't actually have the same sort of system, and so when we talk about volcanism on Venus, it's a very different process. And not only do we see kind of these outflows of lava, but we actually see what we call subduction as well. So there are parts of Venus that sort of swell up because of lava, but there's also parts of it that sort of sink down as well, which is really interesting when we're trying to understand what's happening on the surface of a planet.
And what I love about all this, obviously we're talking about the missions that have been to Venus. Until they really went there, one of the prevailing theories that Venus looked a lot like planet Earth, and it was basically a rainforest.
Lush and green, full of ocean.
Full of oceans and full of life, and it just had a thick atmosphere because obviously the rainforest send loads of water into the atmosphere. And then we went there and went, oh, no. Maybe not.
Clearly very, very different. And one of the things actually that makes Venus quite different is it actually spins in the opposite direction. And this was, again, something that Magellan helped to discover. So using radar, looking at the same point, observing it, the features, as it turned, it realized it was turning in a clockwise fashion as opposed to anti-clockwise, like all the other planets. And there are some theories about what may have caused Venus to sort of revolve or spin in the opposite direction. One of those being a very early, like protoplanetary sized object knocked into it and basically slowed its rotation, and then it kind of started spinning the other way.
Which we see all around the solar system. We think something
Lots
similar
of
with Uranus knocking it over. We're pretty sure it happened to Earth and the Moon. It was kind of a Mars-sized object, and that's what knocked over the Earth and formed the Moon. So not unusual.
Possible. But yeah, really odd to see, because it's not just like a slight tilt. It's almost entirely at 180 degrees.
It's almost exactly 180 degrees, just slightly off, isn't it?
Yeah, so something mysterious definitely happened there. And speaking about, you talked about this idea that we once thought that Venus was this really like lush, Earth-like kind of world. One of the things that has kind of come and gone in terms of our understanding of Venus is, did it ever have water? Or were there evidence and signs of water? Or the idea that water once may have pooled on the surface? And another set of probes that have visited Venus are called the Pioneer probes by NASA. And they actually helped to identify something that might hint at the idea that water would have been present. So they noted when they were kind of surveying that Venus in its atmosphere had a very high level of what we call deuterium. So deuterium is also known as heavy hydrogen. Any budding chemist, hydrogen is the lightest element, and it's basically in its nucleus, in its core, made of one proton. Deuterium is one proton with a neutron. Doesn't really change its kind of characteristics, but it's a heavier molecule. So it's just like hydrogen, and it can replace hydrogen. It's just not the same as hydrogen. I didn't know this, and I found this out. Here on Earth, when we think about water, we know the chemical symbol for water, H2O. But it's known that 1 in 6,400 water molecules...
That's very specific.
on average.
On average, yeah.
Aren't made up of an H2O, but instead are a D2O.
So a heavy hydrogen, a deuterium.
Yes. So the fact is that we know that deuterium is present even here on Earth, and actually deuterium is very much linked to water molecules. And so if we find deuterium on Venus, it's a sign that potentially it could have been there as a molecule present with water, or an atom present in water. And when we look at the ratio of how much deuterium is there and how much hydrogen is there, that can give us an idea on Venus as to how much water, if any water, would have been present. So I think they've talked about the idea that perhaps there would have been enough water on Venus in the past for there to be a global ocean that was about 30 feet deep. So on average, if you covered the entire planet, a 30-foot deep ocean. That's how much water potentially could have been on Venus in the past. The big question, where is it now?
Where is it now?
Where is that water? Because there is none.
I mean, we talked about it in a previous episode about being these kind of almost planetary detectives and alien detectives. You're taking in your evidence and you've just got to find more and more evidence to help prove your theories and things like that. And I suppose that brings us really nicely on to my next kind of question. Are we going to be going back? And if so, what's the point? I mean, we're talking about looking for the evidence of water, or at least where it went. But you also mentioned something really interesting earlier on, which is exoplanets. So planets around other stars, and actually studying planets in our solar system to have a better understanding of, well, the universe and the galaxy and other planets around other stars as well, which is really interesting.
Yeah, I think it's a big question, especially when we talk about the idea that, you know, we're spending millions of pounds on missions like this. And, you know, some of the last missions we sent are over 2 decades ago. We've not really invested heavily in sending more probes to study Venus. In fact, in the more recent years, we've had Venus act more like a gravity assist for other missions.
So we've been there a bunch, but so that we can go to other places.
Yeah, so in the process, we might get a quick image of Venus as they sort of fly by and use it as a gravity assist. But actually, a dedicated mission to Venus isn't something that's really been done so much in the recent years. But from what we've kind of already talked about and some of the underlying mysteries that still surround Venus, we can understand that actually there is a need to go back and explore Venus. Number one, yes, we're curious. As scientists, we want to know more. But you mentioned that it helps us with our understanding of planetary evolution. Venus is a planet that could be the future of Earth. So what we think Venus was like in the past perhaps is a bit more like the Earth. And if Venus has changed and evolved into the hellish world that it is now, understanding how it's evolved and why it's evolved could help us in our future and understanding of what might happen to our planet.
Yeah.
You mentioned exoplanet research. That's a big one, especially with the lessons that we're learning, not just about Venus as a world and its potential near tidally lockedness, but also this idea that it has a greenhouse effect, a runaway greenhouse effect. How much an atmosphere changes a planet is incredible. I think on a previous episode, we've talked about the Goldilocks zone. So this region, a distance from a star where it's not too hot, not too cold, that liquid water can exist. Both Venus and Mars, which are the 2 planets closest to the Earth, are basically within the Goldilocks zone or the habitable zone of our star. But it's the atmospheres that make them, you know, unsuitable candidates. Venus's thick atmosphere makes the planet too hot, and Mars's lack of atmosphere makes it too cold. So learning about that can help us learn about exoplanets in general. And the other thing, which I think kind of brings us back to the Earth as well, is this idea of the insights we can gain about climate change. Venus's climate is, you know, it's a stark example of what happens when you've got an atmosphere, and a thick atmosphere at that. So the lessons we can learn from Venus and what happens in its climate is something we can apply to our own as well.
Absolutely. Now, do you have a little list of some of the missions that are going out there?
I have a few. So
I've got one that is my absolute favourite.
Do you want to share yours and then I'll see what else we've got?
To be fair, chronologically, it makes sense to go first. So it's called the Venus Life Finder. It will hopefully be going next summer. And this is actually the first private mission to another planet. So it's being sent up by MIT over in America, and also Rocket Lab, which is a private launch company. And so it's going to be an atmospheric probe. So you mentioned atmospheric probes delving in. And the thing is, it is only there to do one thing. It's only got one instrument. And I have written it down, so I'm going to have a go at pronouncing it. It's the autofluorescing nephelometer, which sounds made up, which it probably
sounds like something out of Harry Potter, that does.
It sounds very much like a Harry Potter spell, doesn't it? But the whole point of it is aiming to look for organic compounds in Venus's atmosphere. So you've talked on and on about how it's really, really hot on Venus and the pressure is crazy and you could never live there until you go high up in Venus's atmosphere, where actually you can get 1 atmosphere of pressure, so about the same as Earth's is at sea level, and the temperature's pretty nice.
Moderate,
yeah. You'd be fine. Just wear, a nice jumper and a pair of trousers and you'd be fine up there. So it's going in there to see if there are any organic compounds out there. And the way it does that is basically just shining a laser out through this little sort of silicate window and seeing if anything lights up, basically. And if it's fluorescing, that means that it's a good chance those are organic compounds. So I really like that one because, we're not even leaning on space agencies. We've talked a lot about this on the podcast, but not necessarily always having to lean on space agencies to do this really, really cool research. And universities and institutions themselves actually just going, well, we're going out there. And what I also like about this is the Rocket Lab kind of stage that it's going on was also used by Capstone, which was last used. It was last used by Capstone, which was the mission that was testing the orbit of Lunar Gateway, the theoretical part of the Artemis missions. So it all kind of comes back in together. I really love that.
Nice
Rocket Lab are really, really pushing forward for us, and not one that we really talk about. But I really like that.
I also think it's really interesting that this is a life organic finding mission, which isn't something we necessarily think about when we think about Venus as being somewhere that you might find
No, definitely not. Everyone thinks
of
Mars, but actually we're kind of imagining, being a little bit creative and going, maybe there's more places out there that we can think of have
that
life.
might have.
But what else have we got?
So we've got a lot of missions that are actually gearing up to go to Venus, but unfortunately a lot of them at this stage are still in the sort of like proposed, may happen, may not. So one of them is called the Da Vinci mission from NASA. It's an acronym for the Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging.
They love acronyms.
I love that they make it work as well. Someone's job must be to create the names of these missions. I think it would, wouldn't it? But this mission is due to launch in the early 30s. And it consists of an orbiter and also a descent probe. So we've talked about there's not been many things that have gone down to the surface, but this is a mission that has proposed an element that goes down through the atmosphere. So the orbiter is going to be looking at the clouds of Venus, as well as looking at things like the mountains that we talked about. And the descent probe, which is probably about 1 meter in size, so about 3 foot, will be falling through to the surface of Venus and kind of looking at the sulfuric acid clouds along the way, taking some images of Venus's surface if it does manage to get down to the surface as well.
Which is important because we haven't done that, by this time in getting on for over 40 years. Yeah,
it's a very long time. Now, the caveat with this is that it's currently on the list of cancelled missions in the Trump administration's 2026 NASA budget, which is unfortunate. There is another one by NASA called Veritas. This one is the Venus Emissivity Radioscience INSAR Topography and Spectroscopy mission. I'm not even going to go into that, but it is launching around the same time, so about 2031. But this one is actually based on a mission we've sent to Mars previously, so the MAVEN orbiter. So it's using kind of what we've learnt from that and the kind of jobs that it does to basically look at how Earth and Venus are so similar, but why they have become so different. And it's one of the things that we've talked about, I think, and again in this episode, is just they're so similar, but why they're so different. And this mission is destined to try and work out why. But again, very much depends on NASA budget. And unfortunately, there are a couple of missions, or another mission from ESA called the Envision program, or the Envision mission, again, due to launch in the early 2030s. The idea with this is it's going to be using sort of radar to look down at the surface of Venus and again focus on the origins of habitability. So does it have the right conditions? Unfortunately, that radar instrument is going to be supported by NASA. And again, due to the proposed budget for NASA for 2026, that might be something that NASA has to pull out of, which is really unfortunate. It just goes to show that these missions are very, very much needed, but there is a lot of support and money that needs to be invested as well, which may not go through. So I also want to talk about this idea of like private ventures. So you mentioned the Venus Life Finder. So we've talked about the NASA budget and how, that's all happening in US politics, but we're also looking at potentially a new chief of NASA.
Yes.
And someone called Jared Isaacman, we've talked about him previously. He's an entrepreneur. He's, been planning space missions, the Polaris program. He, earlier this year, was a nominee for NASA chief. For some reasons, multiple reasons, he then kind of came off that, and he's now back in the running. And recently, what we've seen in some news outlets is the proposed almost manifesto that he'd laid out has been kind of revealed ahead of perhaps him wanting it to. But one of the things that he's mentioned in there is this idea of wanting to sort of almost reinvent NASA. And one of the big parts of that is actually leaning heavily on private industry within NASA. So it's really interesting that you talk about the Venus Life Finder, because I think for a future of NASA, at least as the way Jared sees it, there is a big part for private companies to actually play in this. Because like we see with government budgets being set here and there, we can't always have guaranteed missions. But if we've got these private ventures, perhaps they can make some headway as well.
And just to finish off, there's a couple more kind of missions that are possibly going out there, which I do want to mention just because they are not NASA or ESA.
Yes, I've got one more. I don't know if it's the same one.
Yeah, go for it.
What's your one?
I've actually got two.
Okay,
one is from the Indian Space Research Organisation, and one is also from the UAE Space Agency.
Okay.
So two missions that are not kind of Western centric. So I think that's really important that we mention those as well.
I think there are also countries that, that aren't necessarily as upfront and forthcoming, but I'm pretty sure China has some Venus missions on the horizon as well.
Must do.
So it's definitely the next place of interest, I think, for lots and lots of space organizations around the world.
Great, fantastic. So hopefully within the next decade or so, we're going to know loads and loads about Venus, and we can talk about it all right here on the Space Now podcast. Now, we love to bring you different ways to engage in space. And this week, we actually have got a special event, Space Lates. Dara, you actually run Space Lates, don't you? So you can tell us all about it.
Yes, so coming up on Friday, the 21st of November, we have our final Space Lates of the year, and it is themed around messages to outer space. So if you want to come and find out about exoplanets like we've been talking about, we've got somebody coming in to talk about like alien linguistics, how we would communicate with aliens should we ever find them, and even things like UFO sightings. So come along, find out about aliens, exoplanets, and messages to outer space.
Amazing. And we shall leave a link from where you can buy tickets down in the description below. But that is all from us. Thank you very much. Thank you, Dara.
Thank you, Ed.
And if you enjoyed this episode, please leave a like and subscribe. You leave a comment down below telling us, should we be going to Venus, or do you have another idea of where we should be heading? And of course, make sure you share this episode with your favourite space nerd in your life. But thank you very much for listening to everyone, and we'll see you next episode.